All right, so prime factorization. In order to be able to do prime factorization, we need to know what are the prime numbers and what are the composite numbers. So let's first start off writing in our notes that all natural numbers, again, all natural numbers, and natural numbers are like 1, 2, 3, 4, 5, all up, okay? All natural numbers are either prime or composite, except for the number 1. All natural numbers are either prime or composite, except for the number 1. So first of all, let's talk about what prime numbers are. Does anyone know a definition for what prime means? What do you mean it can only be multiplied into it once? Can you give me an example maybe? Good. So the numbers 1 and 3, you can multiply 1 times 3 to get 3, which means that 3 is prime. Those numbers, 1 times 3, those are called factors. You heard that word before? Factors. So only 2 factors. 1 times itself. The number 1 times the number itself. 1 times 5 is 5. There's no other way to multiply 2 numbers to get 5. That would be a prime number. Whereas composite, three or more factors. So again, prime has 2 factors exactly, and composite is 3 or more factors. The reason that 1, the number 1, is not prime or composite is because the only way to get 1 is by doing 1 times 1, and that's the same number. So 1 only has 1 factor, so it is not prime or composite. All right, so now what we're going to do is we're going to look at the hundreds chart I gave you, and we're going to identify on the hundreds chart which numbers are prime. All right, so we said that 1 is not prime or composite, so let's mark out number 1. 2 is composite, or excuse me, 2 is prime, because you can do 1 times 2 to get 2. Now there's a trick that 2 is the only even number that is prime. Again, 2 is the only even number that is prime. So that means everything below the 2, those are all evens. Mark them all out. Because they're composite. We're marking out the composites. All of these are even numbers. Mark them out. That column with 4. How do I know that those are even? They end in a 4. What's the next column I can mark out? All of the 6s. They're all even. What else? The 8s, all out. And the 10s, all out. All of those are even numbers. The only even number that is prime is the number 2. Okay? So 2 is prime. So let's think about 3. There's 1 times 3, and anything else? No. So 3 is prime. 5. 1 times 5, and that's it, right? Now, what about all of these other numbers that end in a 5? They're all divisible by 5, correct? Isn't that a divisibility rule? That if a number ends in 5, you can divide by 5? So that means that everything else that has a 5 is also composite. So we're really narrowing it down now. What about the 7? Prime? Prime. 1 times 7. What about the 9? 1 times 9? 3 times 3. So 9 is composite. Only mark out your 9. What about 11? 1 times 11. That's it. What about 13? Prime. 1 times 13. That's it. What about 17? Prime. 19? 21? Why? Why is 21 composite? 3 times 7. 23? Prime. 27? Why? 3 times 9, 9 times 3. Okay. 29? Prime. 29 is prime. Do you guys know the divisibility rule for if something is divisible by 3? So the divisibility rule for knowing if something is divisible by 3 is if you add up the digits, if the sum of the digits is divisible by 3. All right. Tomorrow we will continue filling out our hundreds chart, so please do not lose it. And then we'll talk about how to do prime factorization, and you'll get your assignment then. All right?